Okay, Professor Jim Schultz here from my Finance 512 class. For the Chapter 10 and 11 material this semester, we're kind of doing this using our hybrid structure of this class. And so I wanted to go ahead. One of the topics I want to cover from this material is duration. And so let's go ahead and get started. I've kind of got a kind of an outline here to help keep our discussion focused and on point. So let's go ahead and talk about what duration is. My goal for this video is going to be to kind of talk about what duration is, why it's important, how we can use it, and then I will do at least one additional video on duration where I show you guys how to calculate duration, because I know you guys are going to have some practice problems on this very concept, and this is something I would normally cover in class, and so to kind of replace that or substitute that in-class coverage, I'm going to go ahead and make sure I do kind of a lecture video and then also a problem video. So what is duration? It's kind of a slippery concept to understand in terms of what it's trying to tell you. The textbook definition is duration measures the effective maturity of a bond. Now, I remember when I first read that for the first time when I was learning this stuff, I had no idea what that meant. I had absolutely no clue kind of what that was trying to convey to me. Because, remember, you guys learned from 670, 311, 680, a bond has a maturity date, right? So that bond might mature in 2 years or 3 years or 5 years. So what does it mean if something measures the effective maturity of a bond? How does that relate to its actual maturity? Well, the basic idea is this. If you think of a bond's life, right? Like think of a bond's timeline. You are going to, as the bond investor, you are going to receive some cash flows before the maturity date, right? You're going to receive those coupon payments before the maturity date. So some of those cash flows actually do mature before the actual maturity date. And that's what duration is taking into account. Duration is accounting for the fact that you as a bond investor are going to be paid some cash flows prior to the actual maturity date. And so essentially duration measures how long it takes for the price of a bond to be repaid by its cash flows when you take into account the time value of money aspect of all of those cash flows. And so that's essentially what duration is. It takes into account when each bond payment is occurring and how quote-unquote important it is to that bond. I'm trying to explain this in several different ways because it's a difficult concept for people to understand when they're first introduced to this idea. I really think, I don't expect, based on the last 3 minutes, for you to have a crystallized understanding of what this concept is. But I do hope that that kind of opens up your mind and opens up your eyes so that when I proceed with the rest of our discussion in this video and then show you how it all falls together with a practice problem or two, it's going to really make sense to you. That's kind of my hope. Duration's biggest use is in its relationship to interest rate risk. Now, if you had 311 or 680, you covered interest rate risk. If you only had 670, I don't think it's a concept that I spent any time on, or maybe I just glossed over it because, again, we only have 5 weeks. If this is brand new to you, it's okay. I can bring you guys all up to speed right now. Interest rate risk, well, actually, let's back up. Everybody knows 311, 670, 680, it doesn't matter. Everybody knows, all of you guys should remember that bond prices and interest rates have an inverse relationship. So that means when interest rates rise, bond prices will fall and vice versa. Well, interest rate risk is just extending that concept. Interest rate risk is nothing more than the understanding that all bond prices are not going to move by the same amount when interest rates do change. In other words, if interest rates go up by 1%, let's say, all bonds out there in the financial marketplace are not going to correspondingly increase by 2%. Or decrease by 2% or decrease by 1%. A 1% increase in interest rates is going to lead to all bonds going down, but they're all going to go down by different amounts. And that sensitivity of a bond's price to changing interest rates, that is interest rate risk. So that's essentially what interest rate risk is. What duration is able to do is it's able to give us in one number. It's because duration is measured by time. So duration is usually given in like years or maybe months. It's usually given in years. So by just simply looking at one number, you're able to get a really nice approximation of that bond's sensitivity to changing interest rates. Or you're able to get a nice approximation of that bond's interest rate risk. Because you might remember from 311 or 680, or if you're brand new to this in 670, that's fine. Long-term bonds have more interest rate risk than short-term bonds. And low coupon bonds have more interest rate risk than high coupon bonds. And so there's a bunch of different moving parts, right? Because bonds have all these different characteristics. Some are short-term, some are long-term, some are low coupon, some are high coupon, and so on and so forth, right? Duration, rather than trying to look at it one characteristic at a time and determine a bond's interest rate risk level, duration kind of encapsulates all of that into one number and gives you a kind of a quick and dirty measure of the interest rate risk that might be inherent in that bond. And so it's a really nice way for a bank or a financial institution to look at its portfolio of bonds and determine, hey, how exposed are we right now if interest rates go up? How much is our bond portfolio going to fall? And investors can use this thing for their own personal portfolios. Hey, I've got, X number of dollars in bonds. If interest rates go up, I know my bond portfolio is going to go down, but by how much? That's how duration can help you. So how does duration specifically relate to coupons or time or yield to maturity? Well, let's walk through each one. These are actually pretty quick, and it should give you a better understanding of what duration is trying to show us. Number one, what is duration's relationship to time? Well, remember, what does duration tell us? It's essentially measuring the effective maturity of a bond, or it's basically telling me how long it takes me to get repaid in terms of the price of the bond relative to the cash flows I'm going to receive. So if the coupons associated with that bond go down, so let's say that the coupons that you're receiving go down, so you get a smaller cash flow every 6 months or every year. Ceteris paribus, what is that going to do to that bond's duration? Well, obviously, it's postponing the amount of cash flow that you receive now, right? If your coupon payment was 4% and you were getting $40 a year, and then it drops to 2%, and now you're only getting $20 a year, that's obviously going to increase the duration of that bond. It's going to increase the effective maturity of that bond. Or in other words, since again duration is measured in time, it's going to prolong the amount of time it takes you to get repaid in a time value of money sense. And vice versa would also be true. If coupons go up, duration is going to go down. What about time? What if, ceteris paribus, the time to maturity goes up? Well, if the time to maturity goes up, think about it, right? Before I give you the answer. If the time to maturity goes up, again, what are you doing? You're prolonging the time it takes you to get repaid. So not surprisingly, your duration of that bond is also going to increase. So you have a positive relationship there. If time goes down, then the duration is also going to go down. What about the yield to maturity? The yield to maturity is a little bit trickier. The yield to maturity is not as clean to understand. One thing you should remember from 670, 680, or 311 is that present values and interest rates have an inverse relationship. In fact, that's the reason why bond prices and interest rates have an inverse relationship, because bond prices and present values are synonymous. They are essentially the same thing, since a bond price is nothing more than the present value of all future cash flows associated with that bond. So we know that if the yield to maturity associated with a bond increases, then it's going to reduce the present value of all future payments. That is a certainty because of that inverse relationship. But think about a bond's timeline again. The bigger payments, or the biggest payment, is at the very end, right? When you get that principal payment back at maturity. So while the yield to maturity, while an increase in the yield to maturity reduces the present value of all future payments, it reduces the largest payment at the end by the greatest proportional amount. So that is going to lead to a decrease in the duration of that bond. You might want to rewind that and listen to that again. Because again, it's how quickly am I getting repaid, right? How quickly is this bond going to pay me back in a time value of money sense? And so an increase in the yield to maturity leads to a decrease in the duration of a bond. And now finally, modified duration. What is modified duration? Well, here's the equation for modified duration. I know this is in Word, Microsoft Word, so I'm going to kind of walk you guys through this equation because I'm sure that that's kind of hard to understand when you're just looking at it. Delta P, in other words, the change in the bond's price is equal to, that is a negative sign, and then these first three terms are all in the numerator. It is equal to negative, or the opposite of, the bond's price times the bond's duration times the change in the interest rate level that you are anticipating. All of that divided by 1 plus y, where y is the current interest rate for that bond, or the current yield to maturity for that bond. Essentially, what the modified duration is trying to measure for you, and this is probably it's kind of a, each one of these points kind of builds on the previous point. And so the idea here is we've kind of worked to build up to this crescendo, which this is duration's most applicable use. This is how duration can help you immediately if you are managing a bond portfolio. What you're able to do is you're able to predict the change in the bond's price for a given change in interest rates if you input the bond's current price, its duration, and its current yield to maturity. So you're able to say, hey, I've got a bond portfolio of, $1 million or $500,000 or whatever it is when you retire, or even now. And you're trying to say, all right, I know that if interest rates rise, and with interest rates being at zero, we know they're going to rise very soon. When that does happen, my bond's portfolio value is going to fall. But how much is it going to fall? That's where this equation can help you. And that was my Thinkorswim update, so I apologize. That is where this equation is going to help you. It is going to be able to help you measure exactly, well, I don't want to say exactly, let's go with approximately. It's going to be able to help you measure approximately your bond portfolio's change, or the change in price of your bonds for a given change in the interest rate level. And so that is a pretty nice detailed discussion about duration and why it's important. And again, I'm going to do another video related to duration that walks through how to actually apply this in a problem type setting. So I hope that was useful for you guys, and I will see you guys next time.